Hey guys, I hope that I'm live right now. If you guys are able to listen to me properly, as well as there's no issues with the audio or the video, please do let me know. Hello everyone, I hope that I'm live right now. If you guys are able to listen to me properly, as well as there's no problem with my audio or the video, please do let me know. Yes, no problem. Okay, great. Amazing, guys. Amazing. So we'll start off with our today's class. Okay. We'll just wait for 5 more minutes so that everyone is able to join us today, and then we'll start off with the class itself. Today we are going to focus upon our major numpy. We will be starting off with numpy today, and we'll try to complete as much as possible. Okay. Okay, so up to that point of time, if you guys have any questions, please do let me know. Reliable point of time, guys, do you have any questions? Please do let me know. No issues. Okay, great. The 15 minutes of Python, we'll be covering it whenever the topic comes. Don't worry about it. Okay. We'll be starting with our NumPy from today. Okay. Anjali, we have just started out with the class. So how will I forget to share the attendance link for today? We will be having one upcoming bootcamp that is on Python and data visualization. That is basically exploratory data analysis. That upcoming bootcamp, Prabhat, you can join right over there. We will be learning about Matplotlib, Seaborn, and other EDA analysis that can be done on a particular database. Okay, or a data set. Okay. We'll be waiting for 2 more minutes, guys, so that everyone is able to join us, and then we'll start off with our today's class. Okay. You can join the upcoming bootcamp from our website devtown.in. Okay, so that's our website devtown.in. You can go to the events section and you will be able to see the upcoming bootcamp. So this is the bootcamp that has just started. This is the upcoming bootcamp on Python and data visualization that you are able to see. Okay, all the previous bootcamps as well, you will be able to see down below with the links for the same as well. Okay, so you will be able to see that. One more thing, we have started with our DevTown Bytes, as you're able to see. Now, DevTown Bytes is basically giving you guys some important information that you might need at any point of time. So it has roadmaps, cheat sheets, some videos, blogs that have been put up for you guys. For example, if you go into roadmaps, as you're able to see, you're having the front-end web developer roadmap, back-end, DevOps, Java, Go, Angular, Python. So if you want to see the Python roadmap, okay, so it covers what are the different topics that you need to learn in Python at any point of time and how you should proceed further with it. So similarly, if you want to go into full stack, so let's check out the front end web development bootcamp. So you are able to see all the different things that you need to learn if you want to become a full front end web developer. So all these roadmaps have been put on for you. You can even download them. We have the cheat sheets as well. For example, if you want to check a cheat sheet, let's say on Python, I think so you should be having. So we don't have a boot. Let's say we take up a cheat sheet on HTML. Okay. So you have the HTML cheat sheet where you have any important information in 3 pages, as you're able to see. All the 3 pages are right over here. So all these different things, we have already put it up for you guys. You can download it, you can share it as well. Definitely, I will suggest you guys to explore the same videos, all the previous boot camps and everything. As you are able to see, everything has been made for you guys in such a way that you guys are able to enjoy the learning process. and everything is free right over here. So definitely do check them out and let us know any type of changes that you would like to see, so that we are able to implement that as well. We are trying our very best, so that, for example, this is something that we are currently working upon, the blogs. We are trying to change it, making it a bit better as well. We'll be definitely trying to do that as well. Okay. Usually it takes 1 or 2 days to send out the certificates to everyone. Okay, once a bootcamp has ended, it will take 1 to 2 days to send out the certificates. For the backend project video, I've told you, Siddhartha, again and again, it will be scheduled tonight, okay, after 10 o'clock. No, in real estate, we will not be needing to do the EDA on the data set. Okay, we'll be focusing just upon the modeling. Okay, we have taken up the attendance for day three, Shredder. If you aren't paying attention into the class, not attending the class for the entire time being, you will not be able to get the attendance. Bhavani, which bootcamp have you not received the certificate of? If you're talking about the backend web development bootcamp, it has just ended yesterday. So it will take us 1 or 2 days to send out the certificates. Okay. Okay, so I will start off with our today's class itself. Okay. Okay, so let's start off with today's class. The link always works, guys. There's never a time when a link is not working. Okay. So we need to go to collab. So now in the description of the video itself, you have the okay, so let me just open up the video right now. So this is the video that you guys are currently watching, as you are able to see right over here. In the description of the video itself, as you are able to go down below, the description of the video itself, you will be able to see the link to the notebook. Okay, so this is the notebook that we are going to use today to learn numpy. You're able to see this is the notebook that we'll be using today to learn numpy right over here. So let's do one thing. Let's open up Collab. Okay, inside of Collab, what we want to do is we want to go at File. Okay, we want to go on File and then Open Notebook. File and then Open Notebook. Then inside of that, we need to select GitHub. Okay, inside of that, we need to select GitHub. Instead of GitHub, we just need to copy the URL of the website that we have opened up from the description of the YouTube video. I didn't need to paste it, I just needed to copy. So as you're able to see in the description of the video, you have the link to the notebook. Just have to click right over here. You have to copy the URL. Okay, you have to copy the URL from here. So let's just copy it and then paste it right over here inside the GitHub section. Okay, let's go to the right hand side, click on search, and that will open up that notebook for you guys on your screen. And like I said, it again contains all the notes and everything, so you don't have to worry about it. Again, the notebook is down in the description of the video itself. It will be easy for you to access it from there. Okay, there's a lot that we have to cover. Let's try our best so that we are able to at least cover NumPy today. Okay. At that particular point of time, let me just open up the chat section on my phone so that I'm also able to see your chats. Give me a second, guys. Okay, so I've opened up the live chat on my phone as well. Okay. Now the attendance, I'm able to see the live chat as well. Okay. So let's get started, guys. So introduction to NumPy. NumPy basically stands for numerical Python. Okay, the full form for NumPy is numerical Python, and it's a fundamental package for scientific computing in Python. So basically, whatever scientific computing that you do in Python, you can of course use the Python inbuilt libraries to or do all that calculations at the end of the day. But what happens is it is very slow. We will be looking at why we are using NumPy. I will be telling you guys right now, it will be very slow. Using NumPy would be very, without NumPy, if you're directly doing the computations in Python, like the matrix multiplications and all those kinds of computations, it will be very slow in Python. So some of the developers came together and they utilized different languages to create a package, to create a separate code base called as NumPy. And NumPy is a package that exists inside of Python. You have to utilize it, you have to import it and then use it. Okay, so NumPy is not a part of Python, it's a package. It's a piece of code that has been written by somebody else. And basically you don't know how that code functions, you don't know what is the code that they have written inside of it, but you can just give them some questions and will throw out some output. It's basically the same as using a robot. Okay, so just think about NumPy as a package. Just think about NumPy as a package, as a robot. Okay, you feed in some particular information, you feed in a particular question, and it will give you the answer at the end. It will give you the answer at the end. Okay, so that is basically NumPy. Okay, that is basically NumPy. It's a library of Python. It's basically, think about it as a library. You are having various different books, various different newspapers, various different articles inside a library. You want to get an answer to that particular question, you go to a library, you select a particular book and you read through it. Similarly, right over here as well, any type of computation that you want to do, scientific computation, whether it be matrix multiplications or matrix problems or something like that, then in that particular case, you will be feeding that particular problem statements right over here inside NumPy, and it will be able to change it for you. It will be able to give you the answers. It will be able to provide the computation on that. Now, if you're using, you can do the exact same thing in Python as well, but NumPy provides you some optimizations. There's some mathematical algorithms, some optimizations that are there that NumPy as a package has already implemented for you, so now you are just going to use that tools. Think about NumPy as a particular drill. Okay, you can take up a screwdriver and then screw the entire thing up, but that will take a lot of time. Similarly, if you are having a drill, it also has a screwdriver inside of it. If you are taking an electric drill, you'll be able to do that task much more faster and much more easily because it has some optimizations that is done inside of it. Okay, so that is how we will be utilizing NumPy right over here. Guys, please focus upon what I am teaching. Any type of concept in Python that will be coming up while learning, I will be letting you guys know. We don't have enough time. We have to complete the bootcamp in 7 days. The first 2 days, you guys have wasted a lot of time. So we cannot afford to take up more time right now. Okay, so whatever you guys are learning, we will be able to do it again. For those who are coming up late to the camp, just rewind it and listen to me once again. You are late, we cannot help in that. Okay. Okay, so NumPy basically provides Python with an extensive mathematical library for performing numerical computations effectively and efficiently. That is basically, it provides a lot of optimizations inbuilt for you guys. These lessons are intended as a basic overview of NumPy and introduces some of the most important features that are present in NumPy right now. Okay. Now we need to understand why do we need to utilize NumPy. Like I said, it provides some optimization. It is faster than your normal Python. You might be wondering why people use NumPy after all. Python can handle lists. So you are having lists right over here and you are able to use lists to basically do almost everything. Okay, that you will be doing in NumPy, you will be able to do it with lists as well. But then why NumPy exists? Even though Python lists are great on their own, NumPy has a number of key features that give it advantages over Python lists. Like I said, anything that you want to do in Python, it's like doing everything using stones. If you want to cut a particular rope, you'll have to first sharpen the stone. Using another stone, you'll have to use that stone to rub it against the rope, and then that rope will get cut. So what NumPy is currently doing is it has already given you some knives and some scissors that you can use to cut that rope. That's the exact same thing. Okay. One such feature that it has is speed. Okay. One of the features that it has is speed. While performing operations on large arrays, NumPy can often perform several magnitude faster than Python lists. So if Python is taking like 13 seconds to do something, Python will take 13 milliseconds to do the exact same thing. So that is the time difference in time that NumPy and Python has. NumPy would take 13 milliseconds. Python would take 13 seconds. That kind of time that you are able to save using NumPy. The speed comes from the nature of NumPy being memory efficient and form utilized algorithms used by NumPy for doing arithmetical, statistical, and linear algebra operations. Okay. Guys, this is a YouTube video. You can of course increase the quality of the video to 1080p. I don't have to tell you guys every single day how to utilize YouTube. I don't think so. You guys are boomers. You are from the next gen. It should be me asking you guys how to utilize YouTube, not the other way around. Okay. So as you're able to understand from right over here, as you're able to understand, so NumPy has some memory optimizations as well as it used optimized algorithms like arithmetical, statistical, and linear algebra optimized algorithms and memory optimizations that it is able to have. So that you are able to, like, that's why NumPy is so much fast. Okay, so let us try to understand how to, like, let's try to see it practically. How fast is NumPy? Let's try to understand how fast is NumPy. Now you don't need to understand the first few lines of code because this is just to like give you an example of how fast NumPy is. Okay, so what we are doing right over here is we are importing a library called as a package called as time. Okay, we are importing a library or a package called as time right over here. That basically helps you keep track of a time in your code. If you want to get the current time, that is like what is the second, what is the millisecond, what is the minute, what is the hour, what is the day, so that you will be able to get using this particular time library. Again, this is a library which has a lot many number of codes that you can directly utilize to do something. Okay, this is basically the time library. Everything related to time, anything that you need to do with time, related to time in your code inside Python, you will be using this library. Okay, the next particular thing is import numpy as np. Okay, import numpy as np. Okay, so now what you're doing is you are importing numpy, again a package, importing numpy right over here, and you are nicknaming it as np. Okay, you are nicknaming it as np. Okay, so for example, my name is Shaurya, but maybe you are calling me sir, maybe you are calling me Sharu, or something like that. You're nicknaming me at the end of the day. Okay, so similarly, I don't want to write numpy again and again whenever I want to use this particular library. Okay, I don't want to like utilize write numpy again and again whenever I'm using this particular library. So I'm using this particular as a nickname, as an alias. Okay, so as np. So let's run this particular line of code. So it will just connect me to the servers itself. It is allocating me some of the resources right now. Why numpy is taking much less time, as it is still a piece of code of Python itself. Divya, again a very like question. So yes, you can do 1 + 1 on your fingers as well, but a calculator will always be much more faster because it uses some kind of algorithm, some mathematical algorithm, some research paper that is helping you do this stuff very fast. And that research paper, if you are implementing in Python, it will take you thousands of lines of code to the exact same thing. Okay, somebody has written down that 1,000 lines of Python code for you beforehand, so that you are able to just send the data and get the answer. That is why numpy has very fast. Okay, now in the next line of code, what you are doing right over here is we are creating a numpy array. Okay, we are creating an array right over here. So we're using np, that is numpy, that is the library that we have, dot random. Okay, that is we want to have a random. So we are creating a numpy array of how many zeros are there? 1 2 3 1 2 3. So that would be a million, I guess. So a billion parameters, I guess. So a billion parameters. Okay, we are creating a random. So this particular code, you don't need to understand it right now, but basically what this code is doing is it is creating a billion parameter array for you guys. Okay, it's creating an array that contains 1 billion numbers ranging from 0 to 1. It contains 1 billion numbers ranging from 0 to 1. If I'm printing this out right over here, print x. Okay, I'm running this particular line of code, it is basically creating, so it will take, so as it is creating 1 billion lines of code. Sir, I have not received certificate of web development using MongoDB Node.js. Nikita, it has been not been 24 hours. Okay, it will take time to send certificates. Using. So basically this creates, okay, this line of code creates 1 billion numbers, 1 billion numbers inside an array, okay, having values between 0 to 1, having values between 0 to 1. So we have done this so that we are able to create this particular array as soon as possible using numpy. Okay, now this has 1 billion numbers, guys, please remember that. Okay, so now what we are doing is, you don't, again I'm telling you guys, you don't need to understand this particular part of code. We are just trying to show you how fast numpy is. Okay, you are not expected to understand this code. Okay, so we are taking up the start timing. So time.time, okay, time.time basically takes up 1 billion number of numbers inside that array. Okay, by parameters I mean 1 billion number of numbers. Okay, so right over here, as you're able to see, time.time is basically taking up the first time. Okay, time.time is basically taking up the first time, like when this particular line of code start executing. Okay, when this code starts executing for the exact millisecond of the second as well, when this particular code starts executing in seconds, next year, I mean, like it will give you the exact time. Okay, then I'm executing this particular line of code. What I'm doing is I'm using basic Python. So there is a function in Python that we haven't learned yesterday. So you can use this sum. Okay, so we have learned len. Okay, we have already learned len. Len basically you give the list. You give the list to the len function, and it will tell you number of components, number of items present in that particular list. We've already learned about this yesterday as well. Okay, we've already learned about this yesterday as well. You use the len function, len function, to basically get the length, number of items present in the list. Similarly, you are having the sum function. You use the sum function on a particular list to get the sum of all the elements present in the list. You use the sum function on a particular list to get the sum of all the elements present in the list itself. Okay, so right over here, the time basically takes up the time at which this particular line of code starts. Then you are executing the mean, you're calculating the mean by using sum function as well as the len function. You're dividing both of them, and then you are having the time again. So when this particular line of code starts executing, the new time, so if you are having the start time, if you are having the stop time, how much time, so before the code started executing, that is the start time, this particular line of code basically gives you the stop time to calculate how much time this line of code took to execute. Okay, that is basically you will be able to calculate by doing time.time minus start, that's the end time minus the start time. Again, I'm explaining to you guys, time is basically like you are having a stopwatch. Okay, when you click on time, it takes the note of the time at that point of time. So it is like, okay, right now it is, let's say 8 o'clock, 9 o'clock, it's like 8 o'clock 54 minutes 60 seconds 126 milliseconds, something like that. So that will be the time right over here. then this particular line of code gets executed. Okay, it will take some time to get executed at the end of the day. You don't have to understand the code, guys. Please try to understand this. You don't have to understand the code right now. I'm not expecting you to understand the code right now. You just need to understand one thing. Time is just taking the note of the time when this particular line of code starts executing. Okay, whenever that particular code comes up, what is the exact time? Okay, that is being saved right over here. Something like, okay, it's like 12th of June, then like it's 24 20 54 seconds, and then like 128 milliseconds or something like that. Okay, that is the entire thing that it will be saving right over there. Okay, similarly, when it will come right over here, so it will take, like, let's say this took 10 seconds to execute. Okay, this took 10 seconds to execute. Okay, this took 10 seconds to execute right over here. Now you will be taking up, so the new time, when this particular part comes, time, this will again take up the same thing. Okay, so this is like 12 seconds right over here. So we'll copy this up from right over here, paste it right over here. But this time it has taken 10 seconds. So it will be 22. Okay, because this line of code took us 10 seconds to execute. Then time will be noting down 12th June, 20 hours, 54 minutes, 12 seconds. Now it took 10 seconds to execute this particular line of code. And again, it came to time. So now time has a value of 12th June, 20 hours, 54 minutes, but 22 seconds, because 10 seconds has already passed. 10 seconds have already passed. Now to calculate how much time did it take to execute this particular line of code, what you have to do is you have to subtract this and this particular number. You have to subtract this and this particular number. Okay, so if I'm running this particular line of code, as you're able to see from right over here, it is taking some time. So as this particular code will take some time to execute, okay, this line of code will take some time to execute. So it will take some time to execute this 3 lines of code and get us the answer of how much time did it took to execute, calculate the mean using just Python. Okay, and to calculate the mean just using Python. Okay, so that is what we are doing right over here. Roshan, no issues in that, man. You can come, you can just send me your number, okay, as well as your email ID. From tomorrow, you take the class, okay? Don't worry about it. You decide what is important and what is not important, and we'll work according to that itself. Why am I here? Like, all my experience of 6 years working in Python, it's a waste. You come and teach, okay? All this is important to understand why we need Python, why we need numpy. As you're able to see, this is something that we are doing just in Python. Okay, and how much time it is taking. Up till now, that code hasn't run. Up till now, the code hasn't run. Okay, we are trying to calculate how much time did it took to calculate the mean using just Python. Okay, so let's just see how much time it is taking. It will take us approximately 3 minutes to calculate the mean. Okay, as we're able to see, okay, so it took less than that. I think so we got better CPU this time. As we're able to see, we took 83 seconds, 83.5 seconds right over here. Okay, 83.5 seconds to calculate the mean using just Python. Okay, the next particular line is the exact same, but this time we are using np.mean. Okay, we are having the list. Okay, we are having the x right over here, and we are putting up np.mean. Okay, we're having np.mean right over here. So np.mean is basically a method present in the library numpy that directly computes the mean for us. So we don't have to do some x in Linux. It directly computes the mean for you. Okay, so let us run this little line of code. As you're able to see, it took us less than a second. It took us less than a second to execute the same mean using numpy. It took you less than a second to execute the same mean using numpy. Okay, so that is the speed that numpy provides you over just Python. And that is why you need to learn numpy at the end of the day. Are you guys able to understand this? Please let me know. Are you guys able to understand this? Please let me know, guys. Great. So now we'll be starting to learn NumPy. Right now we have understood how fast numpy is and why we need to learn it. Okay, so right now we'll be creating numpy nd arrays as well. Okay, at the core of numpy is nd arrays or n dimensional arrays. That is the full form for nd arrays. Okay, now an nd array is a multi-dimensional array of elements of all of the same type. Okay, so let's try to understand this. You have already learned about matrices in your mathematics. Okay, you have already learned about matrices. Okay, in your mathematics classes. I don't know where you have learned it. Okay, so right over here they were like one dimensional arrays. Okay, that looked something like this. Then you were having your two dimensional arrays that look something like this. Then you were having a three dimensional arrays that look something like this. So you have your three dimensional arrays right over here. Create this. This is how a three-dimensional array looks like. So this is a one-dimensional array, a two-dimensional array, a three-dimensional array, and this is the concept that numpy looks. Okay, this is the concept that numpy looks, and this is basically referred to as nd array in numpy. This is called as nd array in numpy, and that is the crux of the entire numpy concept itself, because it has been made for matrix multiplications mostly, matrix operations mostly. Okay, so let us try to see that. Yeah, you cannot draw 4D arrays. You should be able to understand that. Okay, so in many machine learning problems, you will always find yourself using n dimensional array, maybe 12 dimensional array, a 13 dimensional array as well. Okay, so in machine learning that is possible. Okay, so right for example, just take up an example for image. Okay, if you are having a black and white image, that is nothing else but a two-dimensional array. If you have a colored image, that is nothing else but a three-dimensional array of pixels. Okay, a three-dimensional array of pixels. So a colored image is just a three-dimensional image. Now a video is a four-dimensional array itself. A video is nothing else but a four-dimensional array. So all these different things you will be able to understand when you'll be moving further into data science and web development or machine learning or deep learning. Not right now, but I'm just giving you some examples of how these arrays actually exist in real life. Okay, now there are several ways to create nd arrays in numpy. The following lesson will learn about some of the few ways to create a numpy array. Okay, so using regular Python lists and using built-in numpy functions. So these are the two ways on creating a nd array. Okay, these are the two ways. In this section, we'll be creating nd array by providing Python lists to numpy np array function. It is just a function that returns an nd array. Okay, so basically you're having a Python list, you want to convert it into nd array. So for that you are having the np.array function. Okay, you are having the np.array function, as you are able to see right over here. Okay, so you are able to just put your list, put your Python, your basic Python list inside that function, and it will convert it to a nd array. Okay, it will convert it to an nd array. That's as simple as possible. This is a one-dimensional array that you are able to create. Again, very simple right over here. It is x is equals to np.array. That is the function that you have to use to convert a simple Python list to a nd array as easy as possible. Okay, the next thing is shape of an nd array. Okay, the next thing is shape of an nd array. Another important property of arrays is their shape. Okay, the shape of an nd array is the size along each of its dimensions. So basically you will call this as a one-dimensional array, so it will be something like 1. So it has 1 2 3 4 5. So just 5 units right over here. Okay, that's just, it does not has any depth to it. Okay, it just has 5. It has a length of 5. It is a one-dimensional array. You're having a two-dimensional array of 3 by 3, so the shape would be 3 comma 3 itself. You're having a three-dimensional array of 3 by 3 by 3, so that will be 3 comma 3 comma 3 right over here. Okay, so this is how you are able to create numpy the shape of a numpy array. Okay, it's shape of an ND array. Okay, this is a one-dimensional array, so you just have the number of items, that is 5. You are having two-dimensional array, that is 3 comma 3. Then you're having three-dimensional array, that is 3 comma 3 comma 3. Okay, that is the shape of the, so that is the length, width and breadth. Length, width, just the length. Okay, depending upon how many dimensions does your ND array have. Okay, so right over here, let us see, this is our ND array. As you're able to see, a one-dimensional array that we are creating using Python lists. You're having a list right over here and you're creating it into a NP array. Okay, so then you can check the shape of that particular array by using x.shape. As you're able to see, x has dimension of 5 comma 0. Okay, because like 5, if you're not writing anything, that means 1. Okay, 5 comma 1, because it's a one-dimensional array. So if you're just writing 5, you already know that it is a one-dimensional array. If you're just writing 5, you already know that it is a one-dimensional array. Okay, so x dot shape. Okay, x dot shape will basically give you the dimensions, the shape of that particular ND array. Okay, type of x basically tells you what is the type of the object x. Here x is our n-dimensional array. Okay, ND array, x is our ND array right over here. So if you are writing this particular type of x, you are using numpy.nd array. Okay, numpy.nd array. Next is the x.data type. Okay, we want to check the data type, that is the data type of the objects present inside the ND array. What is the data type of the objects present inside the ND array? Now for Python, okay, it is all integers. Okay, it's 64-bit integers that you call it in Python. So the data type for the objects present inside the array is also int64, that is integer. Okay, int64, that is integer right over here. We can say that the shape attribute returns the tuple 5 comma nothing, telling us that the x, that is the array, is of rank 1. That means that it has only one dimension. Okay, so rank 1 basically means that it has one dimension and it has 5 elements. The type function tells us what is the type of object x, that is basically an numpy ND array. Okay, what is zero dimension array? There is nothing called as a zero dimension array. Like, what will you put inside of it? There's nothing to it. Okay, no, you cannot. So we'll be coming back to it, but you cannot have multiple data types inside this single ND array. Okay, you cannot have multiple data types inside this single ND array. Finally, the data type attribute tells us the elements of x are stored in the memory as signed 64-bit integers. Okay, so now these are integers that are 64-bit in length and these are signed in numbers. Now there is a great advantage of NumPy that it can handle more data types that Python lists. So Python lists, although it can contain different data types inside of it, and NumPy cannot contain different data types. NumPy can only contain the same data type. Okay, NumPy can only contain the same data type, but the advantage of NumPy is it has more number of data types that you can use. Okay, it has more number of data types that you can use at the end of the day, because it is made for scientific computations. It has to be very precise over the data type that it is currently using. It has to be very precise over the data type that it is currently using. Okay. So you will be able to see from right over here all the different data types that are present in Python that we haven't covered. So there are like the int c, int p, int 8, int 16, 32, 64, uint 16, uint 32, 64, float 16, float 32, float 64, complex 64, complex 128. So there are a lot many number of data types that NumPy can use, whereas for Python it was extremely less. Okay. as mentioned earlier, ND arrays can also hold strings. Okay, let us see how to create a rank 1 ND array with strings in the same manner before. So it's extremely simple. So you don't have to do anything. You have to create a list of strings and then use np.array to convert it to a ND array. As simple as that. Okay, you are able to see the shape, the type, and the data type right over here. So shape is 2 comma something, that is 2 comma 1, that is us. You're having 2 elements and just one rank 1, and then you're having class as numpy nd array, and you are having the data type of u5. Okay, a uint 5 itself. Okay, so Unicode 5 data type. Okay, so you are able to see that this is a bit different from your normal Python, because in normal Python you weren't doing scientific computations. Here you have to be very specific about the data type that you are using. There are various different data types that are present in Python, and this is the Unicode 5 data type. Okay, it is very important to remember one big difference between Python lists and ND arrays. Okay, uh, Kumar, please be very patient. We will be reaching to multiple dimensions as well. First, we need to understand everything, okay? Otherwise, you won't be able to understand anything. Okay, so it is important to remember one of the big differences between Python lists and ND arrays is that unlike Python, all the elements in an ND array must be of the same data type, like I've already said to you. Okay, so while we create a Python list with both integers and strings, we can't mix different data types together in ND arrays. If you want to provide the np array function as a Python, so for example, right over here, you are having a list, okay, because you are passing in the list to an ND array and it is having integers as well as strings. So what will the np array function do is that it will convert all the elements to string itself. If it has one string, it will convert all the elements to string. So as you are able to see right over here, all the elements have now been converted to string itself. Now, if in that case, this was a particular float, let us see that the 3.0 right over here. So all the elements will now be converted into float. Okay, as you're able to see, all the elements have now been converted into float. Okay, so it will all convert all the elements into the same data type. If you are having float int as well as a string right over here, if you're having float int as well as a string, then everything will again be converted to string itself, as you're able to see. Okay, so rank 1 will have 5 elements. A 5 elements list is a rank 1. Yeah, rank is also a topic that you have learned in 10th standard mathematics. How are you guys behaving like this? A one-dimensional array is called as rank 1 array. A two-dimensional array is called as a rank 2 array. A three-dimensional array is called as a rank 3 array. The number of elements is irrelevant. Okay? When I was working in deep learning, there's also type of image is an ND array. What is the meaning of that? Basically, images are nothing else but pixel values. Basically, there are a matrix of numbers. That's it. That's an image. An image is just a matrix of number. Now, if you are having a black and white image, that is a two-dimensional matrix. That's a colored image, then that's a three-dimensional matrix. That's the difference. Okay, so let us look at how to create a rank 2 ND array or a two-dimensional array. Okay, now what we'll be looking at is rank 2 or two-dimensional ND array. So right over here, what we are going to do is we are going to utilize our concept of lists. So what is a two-dimensional array? Let's try to understand that. Okay, so what is it? So please try to be focus upon this very much, because I won't be repeating it again. I will be telling you guys once. Please try to listen to this appropriately. Okay, so when you're having a list, okay, so this is a list right over here. This is a one-dimensional list itself. what is a two-dimensional list? Okay, you are having one-dimensional one list right over here, then another one-dimensional one list right over here, then another one-dimensional one list right over here, and that is how you create a two-dimensional list. Just think about this. A two-dimensional list is nothing else but a list of three lists. It is a list of three lists. Are you guys able to understand this? Please let me know. Are you guys able to understand this? Please let me know. Are you able to see? This is a two-dimensional list itself. Okay, this is a two-dimensional list right over here. Okay, you want to, so what is this? This is a list of three one-dimensional lists. This is a list of three one-dimensional lists. Okay, just try to imagine this. You are having a two-dimensional array right over here, two-dimensional matrix right over here. So what you're going to make is, out of it is nothing else but three one-dimensional list, and that has been put together in a list of its own. Has been put together in a list of its own. So each of this list can be represented by a list. Okay, each of this list can be represented by a list. So we can replace each of this list by 1, 2, 3. That is our first list. Then the second list can also be replaced in the exact same way. Okay, so we can replace the second list by 4, 5, 6. Okay. And then you are having the third list right over here. That is the third list that you write as 7, 8, 9. And you are having a list of these three lists. Okay, this is a list of three lists right over here. So the same values 1, 2, 3, that is the first list. 4, 5, 6, that is the second list. And 7, 8, 9, that is the third list. So a two-dimensional list is nothing else but a list of one-dimensional lists. A list of one-dimensional lists. You can represent a two-dimensional, what you're able to see in 2 dimensions, you can represent it as this. You can represent it as this. Are you guys able to understand? See, this is basic IQ. This is like, if you're not able to understand this, you lack IQ. You don't lack, like, this is the most easiest way that I can explain you guys this particular topic. If you're not able to understand this, you need to start practicing upon like IQ building quizzes, mathematical things, okay, so that your your brain starts working faster than expected. Okay. Are you guys able to understand this? Please let me know. Okay, so this is how you will be able to make a two-dimensional matrix as well. As you are able to see, this is the outer list. Okay, then inside of it, you contain the one-dimensional lists as the objects of the list itself, as you are able to see right over here. That basically makes your two-dimensional list. So if I'm printing it out, you are easily able to see that you're creating a two-dimensional list right over here with the dimensions as 4, that is the number of rows, and 3 as the number of columns. So rows and then columns right over here. Then the total number of elements, so you can use y dot size. Okay, you can use y dot size to count the total number of elements inside the list. Okay, inside the nd array. Okay, the total number of elements that are present inside the nd array. Okay, so you can use y dot size. Okay, so y has a total of 12 elements. Y has a total of 12 elements right over here. As you're able to see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 elements that you get from y dot size. Okay. The next is your type again. So the type is nd array, and then the d type, that is basically your int 64 right over here. As simple as that. Okay. Okay, now up to now we have only created nd arrays with integers and strings. we saw that when we create an empty array with only integers, numpy automatically assigns the data type int64 to the elements. Okay, so we have already learned about this as well. If you are creating a empty array with integers or floats, or float and int together, then everything gets classified into float itself. If you're having integers and floats in the same empty array, everything will get converted to float itself. Okay. Elements in the list should be having the same size. That's absolutely clever, guys. That how will you create, like, you are having a matrix. A matrix can be rectangle or square. It's not Antilla or building of Ambani that you are creating right over here. How to identify one dimensional, two dimensional, three dimensions? Just use dot shape method. Okay, you are able to get the shape of the like array. So right over here, the shape of the dimensions is 4,3. That basically tells you that it's a two-dimensional array. It would have been 4,3,2. It would have been a three-dimensional array. Okay, that is using y dot shape. Okay. Why doesn't it change to float instead of string? A great question. Now you think about it. Okay, if you are having a array that has Shaurya as one of its characters, and then you're having two float numbers as well, what number would you assign to Shaurya? Please let me know. AVS, please let me know what number, what floating point number will you assign to the string Shaurya? Which is more foolproof, to be able to convert that float to a string or the string to a float? You don't want to have errors in your code at the end of the day. Okay. Even though Python automatically selects the data type of the ND array, Python allows you to specify the particular data type, okay, that you want to assign to the elements of the ND array. You can specify the data type when you create the ND array using the keyword dtype. So if you don't want Python to automatically assign something to it, if you want to choose the data type of the list that you have, you can do that by using a particular attribute while creating the np array. Right over here, you're having np.array, and then you're having the list right over here, and an attribute that is saying data type as np.int64. You want to create the data type to int64 right over here. So automatically it will convert all the numbers to int64 itself. So if I'm running this particular line of code, you'll be able to see that all the values of the ND array have been converted to int64. Okay, from float 64 it has been converted to int64, because we are specifying right over here while creating the np array that we want to have the int64 as our output. Okay. Okay, once you create an nd array, you might also want to save it in a file in the future. Okay, when you will be having I don't know if I was audible. Am I right? Am I audible to everyone? Please let me know. I'm audible to everyone. Please let me know, because AVS asked a question and I answered it appropriate enough, and like, but still he's asking the same question again. So I'm just asking if am I audible to everyone, or is that the case that whatever I have said, nobody is able to listen to me properly? So everybody is able to listen to me properly. So AVS, I don't know if, like, you are asking a question, so I'm giving the answer as well, but I'm not even able to see your yes. So I assume that you're not able to listen to me properly. So I've already answered your question. I hope that you will be able to understand it. Okay. Okay, so let's continue. Um, right over here, what we want to see is that we sometimes, okay, the numpy array that you are creating, okay, you want to save it for later use as well. You want to create a particular file and you want to save that particular numpy like array in that particular file. Okay, so this is something that you will be doing in the early, like in the later stages of machine learning, when you will be, if you are fortunate enough to learn machine learning to the very end, you will want to save your weights. There are something called as weights in machine learning that you will want to save somewhere to be able to use it at a later point of time as well into a particular file. Okay, so to do that, you are having the np.save method. What basically this does is it creates a file for you called as my array. Okay, this is the name of the file, my array.npy. Okay, it basically creates a file for you called as my array.npy, where you will be able to store this particular numpy array, that is x, inside of it, inside of that particular file. So if I'm running this particular file right over here, it will create a file called as my array.npy. Let us try to find it. Okay, let's try to find it. As you're able to see, it created a file called as myarray.npy. I'm trying to open it up. Okay, because this is an npy file, so I think so it is not able to like read it properly. But as you're able to see, it's having a shape of 5 elements. It has 5 elements inside of it. Okay, so let us close this up. We don't require it. As you're able to see, your array, that is your np.array 12345, got saved inside a file called as in my underscore array dot npy. Okay, my underscore array dot npy right over here, and that basically contains your x array. Now you can send this particular file to your friend or your colleague to use it as well. Now, to be able to reload the value from that file, I want to get the value from that file itself. I have the file, I need to get the numpy array from that file. So for that, you will be using the load function. Okay, so np.load, then the name of that file, that is myarray.npy, will be using this to load the numpy array from that file into the variable called as y, so I'm running this particular line of code right over here. You are easily able to see that we are getting some error. uh Pickled is allow pickle is equal to false. Okay, change this to see if this works. uh Fail to interpret file myarray.npy as pickle. I don't know why this is not working. This should have worked. Okay, let's try to explore it. Numpy load npy dot load. Let us try to look into the okay, how to pickle this file loader, npy or npz. I don't think so. Import pickle should be a problem right over there. It should have worked directly. We shouldn't have got this error right over here. Is this some name error that I'm making? Let's just copy this name file. C P and still getting this error. Let's search for Stack Overflow right over here. I get an error. I used the syntax below to load the npy file and it worked. So let's try to pick up this as well. So allow pickle true. Let's run this and it still work. Fail to interpret the file as a pickle. Containers for which can be created and by saves that respectively. Notify load text. Okay. It's working fine in some of your code. So let me try to just refresh this, I guess. Let's try to refresh this and let's import numpy again right over here. Let's try to run this, run anyway. Okay, I think so this is a problem with Google Colab as of this particular moment. Due to that, it's not working. I think so it should be able to work fine in the local laptop as well. Okay, it should be able to work fine in the local laptop. I guess this is a problem with Colab as of this particular moment. So no issues in that. Most of you guys will be able to use this. Okay, just try to use this on your time whenever you get time. Okay, on your local laptop, it should work. Okay, now it's working. Okay, so now it's working fine right now. I think so. While we opened the file, it got corrupted in the middle. That's why it was not able to it was not able to read it. Okay, so I just rerun the code itself and it's working appropriately. So np.load myarray.npy. Okay, as you are able to see, we are getting 1 2 3 4 5 being saved inside y. That was the array that we saved inside the in the array itself. Are you guys able to understand? Please let me know, guys. Are you guys able to understand? Please let me know. Great. Now you can also use this function to create rank 2 ND arrays as well by combining the it. Okay, so this particular portion will do it tomorrow. No issues. Okay, so nd.reshape will do it tomorrow. I'm showing the attendance link on your screens right now. You can get the attendance link from right over there. Tomorrow we'll be completing NumPy, guys. So please be on time. We'll be completing NumPy and we'll be starting off with pandas. Pandas will be extremely small because there's not a lot of pandas that we are going to use. Mostly we'll be using NumPy concepts itself. Okay, so tomorrow we'll be completing NumPy and pandas, and from day after tomorrow we are going to start with our machine learning concepts. So please be on time, guys, and we'll have an amazing time. Okay, thank you so much, guys. We'll meet tomorrow. Thank you.